Well, here we go, and we're still in Module 6. Today what we're going to look at is the difference between concentration and strength. So the actual outcome that we're covering is conduct an investigation to demonstrate the use of pH to indicate the difference between the strength of acids and bases. But before we can really talk about the strength of acids and bases, we really need to know the difference between concentration and strength. And this is something that in everyday life we tend to use those terms interchangeably, but it's a little bit different in concentration. So often if you have a drink of cordial, sometimes people will say, oh, it's a bit strong or it's a bit weak, when really they're talking about it's a bit concentrated or a bit dilute. So in our everyday practice, some people interchange those terms but are meaning the same thing. But in chemistry, we need to be able to use them specifically for what they're designed. So if we have a look here, the term concentration and strength have those different meanings, and we need to look at what they are. So we've looked at concentration earlier when we were looking at the mole concept, and we've visited a few times since. Whenever we're talking about concentration, we're talking about the moles or the amount of solute that is dissolved into a solution. It's usually measured in a capital M for molar or moles per litre. So if we're talking about a concentrated solution, we're talking about a large amount of solute that is dissolved. In the case of our acids, perhaps we might be talking about a 4 molar solution. And if I'm talking about a dilute solution, that's usually where I may have added more water. So there's actually more solvent for the same amount of solute. So the solution is deemed to be dilute or weak, because there is less of that solute in that solution. Strength, on the other hand, is a different matter. The strength of an acid is actually the degree to which an acid or a base dissociates. So the only way we can really work that out is by measuring its pH. And usually, and we would have seen in an experiment the other day when we did measure pH, we measured the pH of the same chemical. So in this case we used HCl and we also used NaOH. But we used a 1 molar solution and we also used a 0.001 molar solution, and you would have noticed there that the pH was different. So acids in which almost all the acid molecules will ionize or dissociate just to get that H plus ion are considered our strong acids. So those that dissociate more fully are our HCl, our HNO3, our H2SO4. So they're our more strong acids. Acids where it only dissociates a little or ionizes a little are defined as weak acids. So these are usually our acetic acids and our carbonic acids. So conversely, our bases are similarly defined depending on the amount that dissociates in the solution. So a strong base, again, almost all of it will have dissociated, and our strong bases are KOH and NaOH, again usually determined by pH, and bases in which a small amount will only dissociate are considered weak bases, and there were not too many of these that you would have been familiar with, but ammonia was one of them. So if we have concentrations of a strong acid solution and a weak acid solution, but they're the same, then we will notice that the hydronium ion is higher in our stronger acid solution. So say, for example, we were to have a carbonic acid, a 1 molar carbonic acid and a 1 molar HCl, we would presume that the HCl would have a higher hydronium concentration or pH than the weaker solution, and that's because only a proportion of the acid ionizes, therefore there's less hydronium ions in that solution to be measured.